Hello again, everybody. Dr. Tom McNamara here for our course in trigonometry. In this video, we are going to do some more examples that focus on the law of sines. So I'm just going to take a problem out of our textbook and work it as such. Okay, so in this example, we are going to find all the missing parts to our triangle. All right, so the problem tells me I have a triangle ABC. Okay. They tell me that angle A is 46 degrees. They tell me that angle C is 78 degrees. And they tell me that side B is 7.5 centimeters. Okay, so I will need to figure out side A. I'll need to figure out side C, and I will need to figure out angle B. Now that's the easiest part. They've told me two of the angles. I know that all three of them together have to total to 180 degrees. So let's see what I've got so far. 46 plus 78. Well, 46 plus 70 would be 116. So I've got 124 here. So that means that this must be 56 degrees. And if you total these out, you will get 180. So, all right, so now we've got that. Now I know side B, so I'm going to use the law of sines. Sine A over the length of side A should be equal to, got my labeling convention mixed up here. Sorry about that. Side C is actually down here. Side B is up here. 7.5 centimeters. Angle B should open up onto side B like we've been doing this whole time. Okay, and that's going to be important when we apply the law of sines. So the sine of angle A over the length of side A should be the same as the sine of angle B over the length of side B. All right, if that's true, that means sine 46 degrees over the unknown side length A should equal sine 56 degrees over the known side length B, which is 7.5 inches. All right, so we solve for A. We get that A equals, multiply that over, divide that out. 7.5 times sine 46 degrees over sine 56 degrees. Grab my calculator over here. Do the computation. 7.5 times 46 sine equals, divide by 56 sine equals, so I am getting 6.5, and that would of course be centimeters. Let me just do a quick calculation here. 46 plus 56 plus 78 does equal 180. Okay, great, so we've got the angles right. So now we've got side A. Side A would be 6.5 centimeters. And now one more application of the law of sines will get us side C. And you can use whatever you want, but let's do this one. Sine B over B equals sine C over side C. So we fill in all the known quantities, leaving one unknown quantity. sine 56 degrees over 7.5 equals sine 78 degrees over the unknown side length C. All right, once again, we isolate C and get that C would be 7.5 times sine 78 degrees over sine 56 degrees. And now that we've got this expression, we just crunch the numbers on our calculator and we figure out the length of side C. And then we've got all the parts. What the heck, let me just go ahead and finish it off for giggles. 7.5 times 78 sine equals, divided by 56 sine equals, okay, I'm getting 8.8 approximately. Okay, now you can always do a little check if you're getting in the ballpark. Okay, the smallest angle opens up on the smallest side, and the biggest angle, the 78-degree angle, does open up onto the biggest side, so we've got that going. So the answers are at least reasonable, okay? Let's do another example. Okay, so in this example, we are going to use the law of sines to show that it is impossible to have A equals 30 degrees, B equals 20 feet, and A equals 2 feet in triangle ABC. So let's see what's going on here. The law of sines tells us this, okay, sine A over the length of side A should be equal to sine B over the length of side B. Let's fill in what we know. Sine 30 degrees over 2 feet. Sine B, okay, notice my unknown is an angle here, over 20. Okay, now sine of 30 degrees, that's something that we know because we know our special triangle. 30, 60, 90 triangle, right? One of the first things we talked about in our course in trigonometry. Radical 3 goes next to the 30, short side has length 1, hypotenuse has length 2. So sine of 30 degrees is 1/2. Okay, so from here, if this equation is true, then I'd have 1/2 over 2 equals sine B over 20. So I can isolate sine B, multiply both sides by 20, and I get this. I'm getting sine B equals 5. But if I multiply by 20 here, 20 times 1/2 is 10, divide by 2, and I'm getting 5. Now this is a problem. Okay, remember that if I take the sine of an angle, I'm talking about opposite over hypotenuse. The hypotenuse of a right triangle is by definition the longest side. So I'm making a fraction where the denominator has to be bigger than the numerator. So my fraction cannot be larger than 1. But this is saying that the numerator is 5 times as large as the denominator. So that's a problem. Okay, this is impossible. You can't have the sine of an angle being 5. So there is no such angle. Okay, so that's an example of using the law of sines to show that a certain situation is impossible. Okay, the leg lengths and the angles just won't work to make a triangle.